All right, this is our senior project proposal for a billiards live aim assist system. I'm Joseph Shipley.
And I am Dallin Keever. Okay, so our motivation for this project is that there's a relatively high interest in the game of pool or billiards among the public. It's a fairly well-known game. Most people have heard of it or at least played some kind of variations of it. And the market is mostly made up of casual players, but there's also a very large market of bars and pool halls. And it's a competitive sport, so there is a market for training tools. However, the issue is that there's not really any training tools available, so most players have to teach themselves, which can be difficult when you're first starting out and trying to figure out the angles of the game. It's fairly involved. So we aim to provide something that provides real-time feedback to the user. Since no current training tools provide that, they're all fairly static. And very expensive at that. So
So in regards to the training tools that exist currently, there's a lot of issues with them. They're difficult to use. They don't actually provide a lot of or any real-time feedback. They're just static. And specifically for the game application, they don't provide the user with any help in regards to muscle memory, hitting the right shots. And so overall, these training tools aren't very helpful to specifically novice users.
So what we're proposing is the live aim assist system. So this is going to be a system comprised of various modules. It's going to be made up of a Raspberry Pi as the central processing unit. This is going to be directly interfaced with an overhead camera, which is going to be responsible for capturing the state of the game. And then the feedback in regards to the actual angle that the user needs to hit the ball at is going to be relayed back to the user through this LED indication, angle indication feedback strip, which ideally will be communicated with wirelessly between the processing unit and that module. This is to facilitate a non-invasive gameplay environment where the user can use the tool without having it obstruct their shot or change the gameplay in any major way. So we're aiming to provide real-time feedback, and this will allow the user to actively adjust their shot angle mid-play without any game change to their gameplay dynamics. And the goal here is to be compatible with all different types of cues. We are going to be developing the system on a test cue. So the first iteration will likely be on a single test cue, but the idea here is to be compatible with all cues.
So for the technology that we have going for this project, we've got quite a bit of hardware that's going to be assigned to it. We've got the Raspberry Pi that will be the main source of the processing power under our project. We've got the Raspberry Pi camera that will be attached to that will be taking pictures of the actual pool table and then sending those pictures through the software to be processed. Then we've got the LED strip that's going to tell the user how accurate their Q-tip is located for the best shot. And then we've got the Wi-Fi enabled microcontroller that's going to communicate with all these different hardware pieces and tell them what to do. And we've got this Bluetooth module that will communicate with the LEDs and the Raspberry Pi, and then a power supply to provide power to all these pieces. On the software side, we are going to leverage the Python libraries, OpenCV, NumPy, Pandas, and SciPy. NumPy, Pandas, and SciPy will help with the mathematics behind our algorithms and calculating the best shot angle. And OpenCV will be used for the image processing portion of this project. And then we'll be using Visual Studio Code to as the IDE for all of this software.
So in terms of relevant coursework, I have completed signals and systems, embedded systems, digital systems, data structures and algorithms, and probability and statistics. So these courses will serve as kind of the foundation of the theory and the skills that are required for this project. And then also planned our advanced algorithms, image processing, and convex optimization in the fall. And these are going to really help bolster our skills in the realms of the algorithm side of the project, the path prediction, and then obviously the image processing is going to be a very large part of this project. So we're going to be taking that as well.
And then on my schedule, I've got a pretty similar schedule to Dallin's. I've taken signals, embedded, digital, province stats, and then additionally, I've taken microelectronics too, which will help a little bit more with the hardware side of things. And I'll be planning to take control systems, which will hopefully help as well with the hardware side of the project.
So for cost, it's a relatively cheap project. The big ticket item is the Raspberry Pi Model 4B, and we've gone with the 4 GB option in this price model, but those can range up to about $75 for the larger capacity 8 GB, which the potential need for that is there. And then the camera module, LED strip, and microcontroller, Bluetooth module, and power supply are all relatively cheap as well. So the total comes out to be approximately $116 if we were to go with the 4 GB Raspberry Pi. And then all of the required software is free and open source, so no cost associated there. And then as far as the billiards equipment that's going to be required for the test fixtures, I actually own all of the necessary equipment. I have a 6-foot pool table that we'll be setting up test fixtures on. And this is a very portable pool table, which will be very beneficial for demonstrations and any testing or relocation that's required. And then for the labor, all associated labor is going to be unpaid, seeing as this is a senior project.
For our milestones in this project, on the hardware side of things, we want to make sure that we have all of our requirements down that will be needed for the whole system. We want to make sure we've got a layout that's solid and works. And then we've got the components that we'll need to acquire. So that'll take some time to do some research on those and making sure we're getting the correct components. And then obviously setting that up and verifying that they work together. We'll need to get the peripheral interfacing working, and then get a prototype development set up. The Bluetooth, we'll need to make sure that's working properly, and the communication with the LEDs and the Raspberry Pi. And then the test fixture that will go on the billiards table will be another step in our project to make sure that can actually get the right angles on the taking pictures and things of that nature. So, and then the last thing will be a lot of testing and debugging for the hardware side of things.
And then on the software side, we're going to be solidifying the requirements. Obviously, this is going to have more to do with making sure that our hardware can actually facilitate the algorithms and the image processing that are going to be required for the project. And then set up our development environment once we've verified that everything will work. And then set up our operating system and any required libraries, software on the Raspberry Pi. And then once we get all of that installed, we can work on successfully capturing an image of the table and make sure that we can actually manipulate the image and extract data from that, useful data. So from there, we can work on ball recognition and cue recognition to actually locate objects on the table using that image. And then once we have an idea of where everything is at on the table, we've reached those milestones, then we can actually begin the bulk of the work on the path prediction. So we've got the locations of the ball, the cue, the pockets, and everything of that nature. And then you can actually work on the path projection algorithm and work on optimizing that, getting it fast enough for real-time feedback, and then testing and debugging. And the software side is going to be ultimately an iterative process. It's going to take a lot of trial and error, and it's kind of an agile development cycle. So with that, there's going to be a lot of testing and debugging throughout the process, but we've got that as kind of a final milestone to really test and work out the smaller kinks prior to demonstration.
All right, and then so for our timeline for our project, the first chunk of that will be doing research on the protocols, the peripherals and power requirements associated with our project. And then once we get into fall semester, we're going to start developing a schematic and getting all the components together for the project. Following that, we're going to start working on the software and hardware environments and getting those all set up and working. And then hopefully during that semester we can actually get some of our hardware to work properly, such as the camera and getting the image capturing working. And then we're going to do the object recognition, the trajectory prediction algorithms, and then starting in spring semester, we're going to start to get the user interface pieces working properly, and then we'll have a lot of testing and verification to do to finish it off.
So the deliverables for this project are going to be obviously one fully configured programmed Raspberry Pi Model 4B, and it's going to be installed with the Live Aim Assist software and all the necessary connectivity modules with the camera module and any wireless modules that are required for communication or any power modules. And then at least one addressable LED strip. We plan to have at least 11 to 17 individual LEDs. The more LEDs, the more accurate we can get the angle indication for the user. And they're going to have those installed on a test cube, ready to interface with the Raspberry Pi and ready for testing and demonstration. And then one 6-foot billiards table. This is the one that I own currently, that we intend to equip with the test fixtures and tracking markings, or any necessary tracking markings for the prototype testing and demonstration. And then one programmed LED microcontroller that will successfully interface with both the Raspberry Pi and LED strip. And then in terms of software, we're going to deliver a ball path prediction algorithm that is at least, we aim to be at least 90% accurate in indicating the shot angle to the user. And that's relatively subjective. So we're going to base that on non-bank shots, unobstructed non-bank shots. So a clear path to the pocket, and we're going to assume, the algorithms are going to assume that the Q-tip hits the center of the ball every time and is a straight shot. So we're not going to account for any curve balls or any sophisticated shots. Like we had discussed earlier, it's more of a novice tool to kind of get the angles down rather than complicated shots. And then image processing software that can recognize cue ball, target ball, and the cue position within the table bounds. And this is going to not only recognize the cue ball and the cue position, but also the cue position relative to the cue ball. That way it can understand the angle between the two. And then finally, we're going to deliver written documentation and a user manual on how to set up and operate the Live Aim Assist system. And this is going to encompass both the hardware and how to set up the hardware, as well as a design document that illustrates the design of the hardware itself, as well as documentation on the software and how the algorithms are actually developed and how they work.
So overall, this we believe that this project will provide an affordable and user-friendly experience for both novice players and players that have a little bit more experience to try to work on their techniques and making sure they can hit clear shots properly. And we believe that it'll be a fun and entertaining training system for any user, really. And due to the low cost and user-friendly capabilities that we're hoping to implement with this project, we believe it'll be really profitable if taken to the market.
Though we don't intend on taking it to market, we also think that it'll be a really good learning experience for us and a good chance to demonstrate our engineering competence and get to use our skills for something that could be really interesting and really fun for both of us. We both like to play pool, so it could be certainly an interesting project.